Okay, we're given a trinomial that needs to be factored. In order to do this, we first need to consider the two numbers we're looking for. They multiply to be negative 30, and they add to be negative 13. So if we list out our numbers that multiply to be negative 30, I am not just listing this set, because actually none of these numbers multiply to be negative 30. I would need to make one of them negative. Now we're good. But when we do this, we also need to consider the other pairs when we make the other side negative. So all of these could be negative then. Now, which of this set adds to be negative 13? That would be this one. So that means when we throw our final answer together, our first terms will be b, and our second numbers will be a positive 2 and a negative 15. Okay, so now I have a trinomial, but instead of just using one variable like x, I have two different variables involved with it. That's okay, we can still try to factor this. In thinking about what our answer is going to look like, I know that this is going to be x squared. If you look at our first term, it's x squared. I know there's going to be an x here and an x here. But in order to get these terms with an xy and the y squared here, I know these terms right here will also have a y, because this is how I'm going to get the y squared, y times y. Now to get 21y squared, there needs to be a number in front here that multiplies to be 21. And in order to get this negative 10xy, my outer terms will be an xy, my inner terms will be an xy, but the numbers in front need to add to 10. So this is, again, the same kind of problems we were just dealing with. I need to find something that needs to multiply to be 21 and add to be negative 10. So let's list out our factors of 21, the positives and the negatives, all the possibilities of multiplying to be 21. Do I see two that add to be negative 10? You betcha, right here. That means this is going to be negative 3, and this is going to be negative 7. If I want to try to check my answer, FOIL this out, I should get this. To factor when there's multiple variables involved, we're using the same steps. If we think about what our answer is going to look like, I know that the first terms are going to be m's. Now this last term must have an n in it. But there also has to be numbers in front, because this times this needs to be negative 56n squared. I'm still looking for something that multiplies to be negative 56, but they need to add up to be 1. Positive 1. So let's consider our factors of 56. We have 1 and 56, 2 and 28, no 3, 4 and 14, 7 and 8. Now I'm looking at negative 56, so I need to make all of these guys negative, but then write their pairs over here. And all of these could also be negative. Now which of these pairs of numbers add up to be positive 1? This one right here. So I know up in my final answer I'm going to write a negative 7n and a plus 8n. Final answer. Alright, to factor this trinomial, I'm going to first consider what I know about my final answer. I know that these two need to be 1, because 1 times 1 equals 1. That's the only way that that's going to happen. Now I know that these two multiplied together are going to be this last term right here. And I know that both of them have to have an m and an n in order to get the m squared n squared. Now then there's going to be some numbers in front of these, and they're going to multiply to be negative 100. But because of my middle terms, my outer and inner terms, I know they have to add up to be 15. So let's consider which numbers we're looking for. If I write out all my factors of 100, I know that it's not actually these pairs because one of them has to be negative. So I will write their corresponding pairs over here. And now these can be negative. Now, which of all of these pairs that multiply to be negative 100 add up to be negative 15? Right there, the 5 and the negative 20. That means up in my final answer, one will be plus 5, one will be negative 20. Alright, so what happens now if the order seems all switched around? I have my plain old number first, and I have my squared term last. Now, I am still in order of powers. I have my lowest power first, then the s squared, so I'm okay. If the powers weren't in order, we would have to rearrange it, but we can factor it like this. So let's first think about what those factors would look like. I know that my last term needs to be an s and an s. That's the only way I'm going to get s squared. And I know that my first term, whatever these two are, they will multiply to be negative 64. Sorry, positive 64. The question is, what will those also be so that my middle terms will be negative 20? It's still the same problems that we've been dealing with. It's going to multiply to be 64 and add to be negative 20. So let's create our list. 1 and 64, 2 and 32, 4 and 16, 8 and 8. Along with these, I could have any of their negatives as well. Now, which of these pairs add to be negative 20? You got this guy right there. So that means up in here, negative 16, negative 4. Put a plus sign in between, and we are good to go. Now, if the answer in the back of the book, however, is going to show you this, we need to determine, did we get the right answer? Are they equivalent, or is this different? Now notice that if I switch around this order, because I can switch around the order in addition sign, an addition problem, s plus negative 4 is the same as this. If I switch around this order, this is the same as s plus negative 16, which is this. So sometimes the book might not match up with what you have, but if you know that you can FOIL this and get your original, you're good to go.